All right, good morning. Welcome back to trigonometry here. So we are going to be looking at the next problem for our practice test. So here we go. We have a 6 cosecant cubed minus 16 cosecant squared plus 21 cosecant minus 56 is equal to 0. Okay, so in Algebra 2 or in college algebra, you do learn some interesting ways to factoring out higher degree polynomials. It's related to what they call the rational root theorem. And I'm not going to be giving you a problem that's going to require that kind of a technique. Okay, almost all of the problems, actually, I should say all the problems should be able to be factoring by grouping. There's also a difference of cubes or a sum of cubes problem that you should be able to factor. Something like this, x cubed plus 1, and be able to factor that. I will not be giving you any of these either, okay, because that, you have to do like an x squared, x plus 1, and then have an x squared plus x minus 1, I think. No, minus x plus 1, that's it. So there is a way to like factor these things, okay, that you have to go back and look up, but I'm not going to make you go back and remember how to do that. All right. So these are always going to be factoring by grouping. If you're ever confused, like, I don't know how I'm going to factor this, there's different things you should try. I would always say first pair, second pair is usually your first best go-to because most of the factoring problems in most books are written as first pair, second pair. Sometimes they're easier to group as like a 1, 3, 2, 4 kind of a beat thing. That's another possibility. And then there is a place in intermediate algebra where you factor a 3 and 1 kind of a thing, but those are pretty rare problems. So like that does happen. Uh, what you're looking for is something like an x squared plus 2x plus 1 minus y squared, something like that. This would be a grouping by 3 and 1. This is going to look like x plus 1 quantity squared, grouping the 3 and the 1 minus y squared, and then we could go ahead and do difference of squares for that. Again, not an issue that we're going to be worrying about. So for this problem, let's go back to first pair, second pair, and see what's going to happen. So in my first pair, I'm looking at, we have, it looks like a what's common to both of these guys, there's at least a cosecant squared. Okay, there's cosecant squared. I'm thinking about this as also there's both of these are even. So how about we pull a 2 cosecant squared and see what we have left? So if I pull a 2 cosecant squared of both of these guys, we have a 3 cosecant theta minus, and I pull it out of 2, that's going to be an 8. Okay. And then for the second pair, 21 and 56, hey, those are both divisible by 7. How about we pull out a plus a 7 and we'll just leave that alone? So that's going to be a 3 cosecant theta minus, okay, 8 times 7 is 56, so minus 8 is equal to 0. And then here we go with, hey, these are the same. Go figure. Who would have thought? So we're going to have a 3 cosecant theta minus 8 parentheses, and here we have a 2 cosecant squared x plus 7 equals 0. So here we're going to go with this. We either have 3 cosecant theta minus 8 is equal to 0, or 2 cosecant squared x theta, because we use the same variable, plus 7 equals 0. Now, this term here only has complex roots. So we're not going to be dealing with complex on this exam. So anything that's imaginary, you can safely throw that away and say, that's not an answer. This has no solution. Okay. So we don't need to deal with that. And then we're stuck with, or we're left with 3 cosecant theta minus 8 is equal to 0. So we have 3 cosecant theta minus 8 is equal to 0. Let's go ahead and solve that. So we could say we have 3 cosecant theta is equal to 8. Cosecant theta is equal to 8 thirds. Now, I go to my calculator and I don't have an inverse cosecant on my calculator. So I'm going to have to say, what is cosecant? And it's 1 over sine is cosecant is equal to 8 thirds. And now we're going to have to go ahead and multiply both sides by sine thetas. Okay. And then we're going to go ahead and so we have 1 is equal to 8 thirds sine theta, and then we're going to undo get sine theta by itself, multiply both sides by 3/8. Okay, so we have sine of theta is equal to 3 over 8. This is not a ratio that you should know off the top of your head. This is not related to your unit circle. So we're going to say theta is now equal to the inverse sine of 8 3/8. Okay, we're going to have to go to the calculator for that. Okay, so we're going to go ahead and take a look at that one. Come on, calculator, where are we, calculator? There we go. Here's a calculator. Nope, I don't want that. Come here. Here's a calculator. So we have the inverse sine of 8/3. I'm going to double check to make sure. Am I in degree mode? I sure am. And the instructions of the problem say come up with a calculator, come up with a decimal approximation to two decimal places, and that's going to be good. So we want inverse sine of 3 divided by 8 in degrees, 3 divided by 8. Okay, there we go, 3 divided by 8. And then we'll go ahead and type that in. So we end up with theta is equal to 22.02 degrees. Okay, now where else is my theta equal to my positive number? It's also positive in quadrant 4. So I also need that angle. So usually for reference angles, we go to the horizontal. How much more do I have to go here? So we're going to say this is 180 minus 22.02, and that is my other angle that we're working on here. Okay, so we're going to say 180 minus 22.02. All right. And we also get an angle of 157.98. So theta 1 is equal to 22.02. Theta 2 is equal to, and I'll go back and look at this. And it looks like we have 157.98 degrees, 157.98 degrees. And those are my answers for this equation. Okay. So that's how we're going to go with those. Again, don't get too intimidated by the factoring. Try a first pair, second pair, and then see what happens. And then you can go ahead and factor those out. Okay. So thank you very much for watching the video. And I'm going to say I'll see you on the next one. Okay. Take care. Take care.